Any other details, Dr. Zhang and Dr. Kao, before we get started today?
No, I just want to make sure that everybody has installed R or R Studio so far. And
I would anticipate that not every person has, but I think that a lot of people already have, and hopefully here real quick, especially before tomorrow's hands-on activities, they will get it. And then we can add it to that shared document that I shared with you, some technical, some how-to steps. We can do that later on today so that you can be all set for tomorrow.
okay, yeah, right. Even if you do not have R or R Studio installed for today, you can still copy and paste those R programs into R once you have it on your computer. So yeah, okay.
Well, everybody, you know how kind and generous Dr. Zhang and Dr. Kao and their team has been. So thank you very much, Dr. Kao, and let's get started. Thank you.
Yeah, thank you, Elmer. So everybody can see my screen now, right? Okay. Again, if you have any questions, just put them in the chat box. Peng Tao will try to answer them for you, or if I see them, I'll try to answer that for you. Before we continue, before we pick up from where we were left yesterday. I just want to have a review of what we did yesterday. So we talked about the most important ingredients of R, which are called packages. So this is how a community of R programmers or R users, how they contribute to this whole this whole research community by making up their own programs from their own research fields, so that everybody else can test the package and also implement the packages quite easily. And these packages, so they can be written in different languages other than R. For example, some of the packages might be compiled using C or C++, so that the programs could be the computational efficiency of these programs could be highly boosted, because we know that the R language is not a very computationally efficient language, but it's very easy to use. So sometimes for computation with very large scale data sets, you do want to have a very computationally efficient way to solve the data analysis for those large data sets, or for many data sets of similar structures. Okay, so this is a very important when you want to do something. For example, if you want to say, oh, I wanted to perform linear regression, or I wanted to perform a hypothesis testing, or I wanted to do some kind of clustering or fancy clustering technique, or I wanted to use a neural network for or other deep learning methods to analyze my data, then they may not already be available in R. Then you can just search Google R package, like neural network for deep learning. Then many of the R packages may pop up for you to use. Okay, so then you don't have to write your own programs, and other more proficient programs have already done that for you. Okay, so as you start to use R more often, you will know that you will access or install more of the R packages into your R working space. Okay, but until you have installed a package, you won't be able to use those functions. Okay, and every time before you want to use the package, you will remember to load the package using the function called a library. Okay, and these are so these are some of the very 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 important ingredients in our programs, and just like the other programming languages like MATLAB, they have their own packages. C, they have their own packages as well. Okay, so and we have also introduced some useful shortcuts. I'm not sure. I trust that you guys might have tried these useful shortcuts by yourself after the class. Tab key and up and down arrow to navigate through the commands. And there are also some of the help resources for you to get help on a certain function or a certain research topic that you wanted to use. For example, how I want to get some help on linear regression, and I can just type in help.search linear regression. So it will, so some of the functions or documentation pages will pop out from R so that you can get some help from that. Okay, or you can just get help for a certain function using the help function. And also, there are some of the basic tricks for you to play with the working space that you currently have. The list function that can list all the R objects that you are currently using in your working environment, and also the directory that you're currently under. Sometimes you have multiple projects that you are working on, and you don't want to mess between different projects. So you wanted to have different directories for different projects that you are working on. And you can check the current working directories using this function, get a WD, and you can also intentionally set up the working directories that you wanted to working on. And if you already have a function or an R script that you have, then you can just source this R script so that it will automatically, or the functions that are stored in this script will be automatically loaded into your R working space, so you can directly use them. Okay, so all these script files, they their file names ended with a .r extension. So so many times when I write my R programs, in order to make it a very clean script, I often work with two files. So one file is called a library file, and another file is called a testing file. In the library file, I write chunks of code where each chunk is a function, so that before I use my code in the testing file, I can just source the functions in my library file. So all the functions in the library file will be loaded into my working space before I need to use them in the testing file. So the good thing about having a library file in addition to the testing file is that in this way, I could then have a very short and concise testing file for me to use, and I don't have to constantly change those function files. Okay, and when I do need to change the library files, I can go back to the library file and edit them. Okay, so these script files allow you to store functions or some of the simple commands that you have in files. So when you want to come back to this project, and you can easily manipulate this codes or R programs. Okay, so, and we also talked about how do we set up our working directory. And there is, like I mentioned, there is a little bit of difference between PC and a Mac in terms of the directory, regarding whether you should use a backslash or a forward slash in PC or in a Mac. Okay, so this is the working directory that I will be using. So when I call the function get working directory, then I'll see, okay, this is where I am. So I won't, so then so that I know, yes, this is exactly where I want to be, and I don't want to be on my desktop, because my desktop will be overwhelmed with all kinds of files or temporary files created from running the programs. And the biggest part of yesterday's lecture is on data types. So we introduced about the atomic data types, which include logical data, integer data or integer values, numeric values, complex values, characters, or raw data types. So we commonly deal with numeric and the characters, and these are the two most important atomic data types that I actually use, because as a statistician, I deal with numbers every day, and sometimes when I read and those numbers are those numbers are observations collected from various of participants or subjects or individuals, and sometimes the features might not all be numeric. For example, the gender of a person, you cannot use a number to describe the gender, so you will use a character to describe the gender, female or male. And but for other features like weight and height, then you can use numbers to denote those features for the subjects or the participants. So these are the two most important atomic data types that I deal with, and probably you will be dealing with. The and we also talked about different data types. They have a different they require different memory to store them in the working space. So sometimes if you want to write a highly efficient programs, then you may want to specify what kind of atomic data types that you are dealing with today. But honestly, it is not a very, like I said, it is not a very computationally efficient programming language. And if you do want to write a highly efficient program, you may want to write those very basic functions, or the most time-consuming steps. You may want to write those programs in another language, like in C, to save the memory or save the space. But in R, it is more for those um, statistical summaries or statistical visualizations. Um, so um, so 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 that so that being said, I don't often care too much about the memory cost or the um, time consumption in R. But after I finish my testing my programs, I will say, oh, this is not very efficient. This takes an hour to finish the program. So I might, but it is working very well. So I want to switch to another language, like a C or C++ or even Python, so that the algorithm will be the same, but the way to implement the algorithm will be different. Yes. Any questions? Okay. I just saw a comment from Laura. Can you give an example of what list all our objects in current environment means? So this is meaning that, so this is my R console, and I want to see what kind of, okay, no, I don't have anything here yet, but okay. So for example, I use the list function to list all the objects that is currently in my working environment. This is meaning that I want to check what kind of variables that I have already created in my R working space. Like I just did, I created a variable called AA and a variable called BB and a variable called CC. And AA, BB are two numeric variables, and CC is a character variable. Of course, I can also create a function called fun. So what is fun? Fun is a function that will return the square to the power of the square of a value. So for example, what is the square of 4? Is 16. So now when I list my everything in my working space, I see that there is a AA, BB, CC, and fun. So this is another function is created. So I will constantly I constantly check the variables in my working space to make sure that for example, if I want to know, oh, I'm going to create another variable, what should I name it? I probably don't want to use a name that I already have it in my working space. For example, I want to create another function, and because I already have a function called fun in my working environment, I probably want to use a different name. For example, I wanted to create another function called a fun1, and this time I will return the cubic of the function. So and now when I check my library, the function called fun will not be overwritten by the new function. So this is why sometimes I need to check the objects in my working environment so that I will not mess up with the names, because these names are, you can name these names, you can name these objects or these variables quite arbitrarily. Okay, and also in other scenarios, like okay, I want to use a function that I have already created, or I want to use a variable that I just memorized. For example, I memorized the student's grade, a plus, a minus, and b. Okay, so these are the grades for the students in my class, and I have created such a variable, but I forgot what I have created. So when I check the objects in my when I check these objects using the list function, then I will see, oh, I created these things. Oh yeah, it's called grades. It's not called grade or other things. It's called grades. So then I can just look at the grades and see, oh, these are the grades for the students. So the use of this ls function or list function is for you to be able to remind you of what kind of objects that you have already created. And these objects can be a vector, can be a scala, a matrix, a list, an array, or functions, or any or other objects that you have created. But um, so this is these are the basic. When you start to use R more often, then and you will create more and more variables in your working space, and then you probably do not remember everything that you have created. Then you will need this function to display what you already have in your working environment. Okay, and another good thing about this list function is when you load your data, or when you are working with the data that you have already saved, and we'll talk about this in a moment. I'm not sure if I have, yes. So for example, when you load the data, I will talk about this in a moment later, but I just want to show, now we are talking about this, I just want to show what we have. So for example, I want to check, so now I have removed all the variables in my working space. See, they're all gone. But when I load this data set, and I want to check what are in this backup.r data. So all the data that you have saved in R, they end with this .r data extension. So you want to know, oh, these are the files that I have saved in my folder. So next time when I want to use it, then I'll just load this data. But what exactly did I put in this R data file? Then I can use list function to check. Okay, there are two variables in the backup.r data. It's called x and y. So you will immediately be reminded of what you were you were doing when you stored that data set. Okay. So, and I will come back to the data loading, which is the biggest part of today's lecture. So we talked about the different data types, a vector, where a vector, a matrix, and array, they simply are objects where each element in the object needs to have the same type of atomic type. So this needs to be either all elements in the vector, in a matrix, or in an array, they need to be all of a numeric type or a character type or a logical type. They cannot be the atomic types in a vector, a matrix, or array cannot be of different types. Okay, if they when you coerce them, when you coerce different data types into a matrix or into a vector, then your data will be then your data might be sabotaged. Okay, for example, if you coerce 1 and AA, then your 1 will become a character in here. Okay, so you remember the C function is a function to create a vector, right? Okay, so when you put 1 and AA together, 1 is a numeric variable and AA is a character variable, and you coerce them into one vector, and 1 is changed to a numeric, and now you cannot perform numeric computations on 1 anymore because it is simply a character right now. Okay, so, and same thing for matrix and array, but sometimes if we wanted to if we wanted to store data types of different atomic types into one data set, then we do want our data types to allow heterogeneous data types, and this is the advantage of using data frame and the list. Okay, so for data frame, you can have different atomic types in each column. Okay, each column could be, but here each column needs to still to have the same atomic types for all the elements in the column. So everything in the same color needs to be of the same atomic type. Okay, so now we have a data frame of 3 different atomic types. This could be a numeric vector, this could be a character vector, and this could be a logical character or a factor character. But everything within the column should be of the same types. So like I mentioned, this could be the clinical profile of patients enrolled in a certain clinical trial, and then this could be their gender, and this could be their BMI, and this could be their some kind of biomarker value. Okay, so they're of different atomic types, and the list is an even more relaxed type of data type to store your data. So you can have data of even different dimensions. Okay, so you can store vectors, matrix, and the data frames in a list. Okay, and they could be of quite a different length. So you can store, so this could be length of 3, and you can also store other vectors of different lengths in this list. So this do not have to be the same. Okay, so anything that you have, you can store them in a list. Okay, and we also tried we also tried a few codes that we create different objects like scalars, vectors, matrices, and the lists in R. Okay, so yesterday we stopped before we use data frames, and so the data, so there's nothing very different from data frame to the other data types, only that the data frame, in each column of the data frame, you can think of that as a vector, and these are the vectors in this data frame. They need not to be of the same ethnic types. Okay, and we will immediately see what after working with. I will come back to these operators and control structures and the functions in a little bit, but I just want to start with working with the data, so that at least we can get the data into our working space before we further learn about analyze the data or visualize the data. Okay, so in this chunk of code, we're going to learn how do we read different files into a data frame. Okay, so we can read a CSV, we can read a file from an online resource, and we can read a file from our local space into a data frame. And we can use read.csv to read the file into your data frame, and we can use fread, this function, to read a CSV file into your data frame. So these two chunks are used for CSV files, and this one little chunk is used for reading Excel file, and this is used for reading text file into a data frame. Okay, so I'm going to open up and see and show you guys. So this athletes.csv is downloaded from this website. Okay, and now I'm going to open up what this athletes CSV file looks like. Okay, so this is a spreadsheet, and the first column is the ID of the athletes, and the second column is the names of these athletes. And you also have the nationality, the sex, the date of birth, height, weight, and sports, and the different medals that they have won for each of the athletes. Okay, so so how do we load this CSV? And this is a CSV file. And how do we load this file into our working space so that I may want to see, oh, how many of them have won a gold medal, and between the people who have won a gold medal, and how many of them are female, and how many of them are male, and how many of them are of different nationalities. So these are some of the analysis that we might, some very simple analysis that we might work on. But before that, we need to load the data into our working space. Okay, so we can either use a read.csv function to read this file into my working space. Okay, so to use a function. So you first call this function and then follow this function with a bracket. Okay. And then within this function, these are the arguments that you should pass on, that you should pass to this function. And the first, how do you know what kind of arguments there are for this function? Okay, so that is when you should use the help documentation for a certain function. Okay, so now I can just say, usually when I type this function into it, okay, as you guys can see from here, so when we call this function, these are the arguments that we should pass on to this function. First one is the name of the file. Okay, so you should tell this function what file are you reading or loading into your working space. And then the second one is called a header. What does header mean? Header means whether you want to make the first row as the as the header of your data or not. Okay, header is the column. You can think of the header as the column names of your data. Once you load the file into your data, you do want to have a column names for each column so that you will remember. Okay, for example, athletes here. So do you want to make this first row? So header basically means, do you want to make this first row as the column names of your data? I think the answer is yes, because you do want to remind yourself of what does the first column do, and what does the second column do, and what about the third and this. So, the third is what is the separator of this file? Okay, for a CSV file, you usually the different fields or different columns are usually separated by comma. Okay, and yeah, this is a colon, yes. And I don't this. So these are the three arguments that we use the most. So coming back to the code chunk in here. So what I'm doing in here is I'm going to read in a CSV file called athletes.csv, and I want to make the first row as the header, and in the file called athletes.csv, I know that the columns are separated by column, and I don't want to skip any rows. So sometimes you do want to skip certain rows in your file, but in this case we do not need to skip any rows in here. So now let's see what we can get from this program. Okay. Okay, so now you can see that I'm able to read in the file called athletes.csv, and I assign the data that I have read in from the Excel file to a variable name called a DAT. And now I'm checking the head. I'm checking when I use the function head, I am actually checking the first 6 rows of this data. So this is a simple way to look at the first few rows of the data. So now I see that, yes, this is exactly what I have gotten from my Excel file. See, the first column ID, name, nationality, sex, date of birth, height, weight, and stuff. And the values are exactly the same as in this Excel file. So yes, I am a little bit of sometimes I'm a little bit of picky. When I read in my data, I do go back to the original Excel file to compare if the data that I have read into my working space, if they look similar to the ones in the original file or not. You know, sometimes they do not, because when they store the data, there might be some corruption when you store the data, and when you read them in, you may need to change from between among different functions to make sure that the data you have loaded into your working space, they are the ones that you need. So apparently the data I have read into my working space, they look exactly the same as the data that I stored in the Excel or in the CSV file. Okay, so this is one way of reading the athletes.csv file into my working space, and then I can make manipulations into my data further. And there's also other ways of reading the CSV file into my working space. For example, I can use another function called fread. It has a very similar functionality as in read.csv, but in order to use fread, different from read.csv, which is a built-in function in R, in order to use fread, you do need to load a library, a R package called data.table. So I was told that the fread function is it is more efficient than the read.csv, but I have not really tested this before. But anyway, these are two different ways that you can read in the CSV file into the working environment. And similarly, for fread, you can also check what are the you can also check what are the arguments that should be passed on to fread. So I'm going to check the first few columns of fread. So it needs an input, which is the path, and it needs an argument called a file, and a separation, and a separator. So it has all kinds of these arguments that you can pass on to fread. But remember, so when you write a function for others, so you do want to make your function as comprehensive as possible to allow people to access different functionalities of your data, even though most of the time only two, even one of the arguments will be used. So you often see a function of like 20 or 30 different arguments that you need to pass on to the function, but a lot of the time you don't need to really pass on anything onto all the arguments, and you may need to only pass on to one argument into the function. That will be sufficient, and the rest of them will stay as the default. Okay, just like what I have done in here for read.csv, you see that they have this many arguments, and you saw these you saw all these dots in here, meaning that there are more arguments than what have been presented in here. But here I only passed on 4 arguments to it, and the rest of them will stay as default. That is set up by the original contributor of this function, or the original developer of this function. So even if you saw a function with hundreds of with too many arguments, don't be freaked out. Most of them will be by default, and you only need to pass on to a few of the arguments onto it. So now here I need to let the freader know what is the file that I need to read, and what is the separator of the columns, and if I want to make the first row as the column names or not, and string as factors, and also if I wanted to make the characters in my file as factors or not. And a fancy functionality in this function called fread is that you can actually select the columns that you want to read into data. For example, here, I'm only interested in the name and the nationality of the data in atlas.csv. So I let fread know the selected columns that I want to use. Okay, so the rest of the columns will be skipped, will be ignored by fread. Okay, so between read.csv and fread is definitely more computationally efficient, but I prefer to use read.csv for myself, because it is very easy to use, and sometimes I don't need those very fancy functionalities. I just want to read my data in. Okay, so this is what I will use. So the file name, and if I want to make a row, the first row as a header or not, and what is the separator of the columns. So these are the 3 most frequently used arguments that I will pass on to the function called read.csv. Okay, so this is how we load in CSV file into our working environment. And many times we also have an Excel file that I want to read it into the working environment. Okay, so before that, I want to make sure that I want to check what is the. So yes, indeed, when I use fread to load into my data, the class the characteristic of the data become a data frame in a data table, and see the so the str function gives you more details on the characteristics of the data that you have just loaded in, and it will even tells you what are the columns in this data. Okay, the next thing we want to learn, how do we load in Excel file into a data table, and you guys should all be able to access these files that using that Google link that I posted in the beginning of the class. So this is one Excel file that I want to load in. This is in fact a gene expression profile for, I'm sorry, for different subjects, for many different genes. Okay, so you can think of these as different features, and this as different individuals or patients. So these are actually all pancreatic cancer patients, and I measured the gene expressions for each patient. Okay, so here each value, so this value indicates the expression value for this gene called MACH1 for this particular patient, and this value measures the expression of the gene called AACS for the first patient. Okay, and I have two sheets in here, sheet 1 and sheet 2. So these are different normalization functions, but you can, but don't, but I'm not going to talk about the more details on the data itself, but just for the, so you know that they are of, so they are, so you have a workbook, Excel workbook, and you want to load data from the two sheets into your working environment, and how would you do that? Okay, so in order to use reading Excel file, in order to use the read, in order to for you to be able to read in Excel file, you need to install a package called a readxl. So this is a very powerful package that you can load Excel file, and there's definitely other packages for you to do that, but this is my favorite. Okay, so for, again, you can also check what is the arguments for, okay, I need to load my package first. Yeah, see, before I use the function, I need to load this package. Otherwise, I won't be, otherwise my program cannot recognize what a read Excel is. So here, this part is telling you what are the arguments that you should pass on to Excel. Okay, first one called a path. So okay, so this is a simple way for you to check the arguments, but in order to get more details on what is path and what is this argument and what is a sheet, what should I pass on to path and what should I pass on to sheet, and what are these other arguments? I'm confused. So when you ask this, then you can get help from here, okay, or you can just Google it. No. So when you get help for read Excel, then what you will see that, oh, this is how this is the different arguments that you should pass on to this function called read Excel, and here this arguments chunk tells you what are these different arguments that you are passing on to the function, and the value chunk here is telling you what does this function return to you once you have used it. So the three, I think the two most commonly used arguments for read Excel are the first two arguments. First of all, what is the path to the Excel file? Okay, and also secondly, if this is a workbook, which sheet should you read from this workbook? Okay, so now I'm going to read in the first sheet of my Excel file, And because this file is already in my is already in the same folder as I am working on, so that I do not need to specify the path to that. But in fact, when I could also do but if it is, but you can try to specify the whole path, the complete path of that file. Okay, you can try to specify the complete path of the file so that you will not so that the function will be able to find the file that you refer to. Okay, and this argument is telling the function, I'm going to read into the first sheet in this Excel file into my data. And I'm not going to skip any rows. And if I saw any missing values in the Excel sheet, I'm going to make it as a missing value. And I do need the column name. I do need the first row to be my column names. So now let's check what did I read into my data. Okay, so see, this is a table. This is actually a table. It's not a table, it's a table. So so a table object is something that you get from this function read Excel. And you can easily convert a table into a data frame by using an argument, by using a function called a data.frame. So this data.frame function will convert the table into a data frame. So now let's check what is the converted file. Okay, so now this is what we want. Okay, so in here it is displaying exactly what we have seen in that Excel file. Okay, the first column being the G names, and the second the rest of the columns being different patients. So here the first expression value is 330, and exactly in here, and so I cross compare what I have read into my data with the file that I have used, so that I'm not reading into anything wrong. So this is something that I do for myself, because there are times, like I mentioned, the file might be corrupted, and what you have loaded into your data might be completely something different from what the file contains or what the file displays in front of you. Okay, so this is how you read it. So definitely you can read from the second sheet by specifying sheet equals to 2. So again, you can convert this into, you can convert the table into a table. Okay, so this is a table, and this is a table. Okay, what did I do? But yeah, so yeah. So the value the value returned from read Excel function will be a table. And let's look at it. It does not show the complete data structures in here, and instead it only shows a small part of the data. You see, there are many missing rows and many missing columns. But once I convert it into the data frame, then I'm able to see what are the values and all the columns and all the rows. But because I use the function head, I'm only seeing the first 6 rows. But if I want to see the whole thing, the R console will not allow you to display the whole thing. It only display only the first few rows, the first 13 rows in this case. Okay, so this is how you will read it from Excel file into a data table. And so the two most important arguments for you is what is the path to the file and which sheet should you read from this Excel file. And for read, so this is my favorite function to read Excel file, and this is my favorite function to read from CSV file. And likewise for read.csv file, what is the path to the function of the file to read into, and should you make the first row as the column names, and should you what are the columns how are the columns separated? Because I don't know how much experience have you had dealing with the CSV file. Sometimes the CSV file are the columns are separated using colon, and sometimes they are separated using a tab space. So if so, that is why you need. But most of them they're not separated by tab, but sometimes they are. So that is why you need to specify this. But this should be right for most of the CSV files. Okay, so again, I'm only listing the most frequently or the most important arguments for you to pass on to these read.csv, fread, and the read Excel functions, and the rest of the arguments, the rest of the many arguments could stay as default, which shouldn't be a problem. And also, how do we read from the text file into a data table? So now I have a text file in here. And this text file is an Irish data set, and it is the columns are separated by colon. And so this the first column is called the length, width, and the petal length and the petal width for different types of iris flower. Okay. So it has 1, 2, 3. It has 5 different columns in here, and to read this file into this text file into it, my favorite function is called read.table. Okay, so this is my favorite function to read the text file into a data table. And the arguments that you want to specify is what is the separator of the columns. So for text file, many times the columns are not separated by column, but instead by tab. Okay. And you also want to say whether I want to use the first row as the column names or not, and also if I want to skip any rows. Okay. So now I have my data loaded, and it is, so this is exactly what I have seen in a text file. Okay. And so these are, so in addition to, in addition to the ways that you can access data from files of CSV files, Excel files, text files, you can also load the data from our data that you have previously saved. Okay, for example, I have created a few variables or objects, and but now I need to close, or I need to shut down my computer, but I don't want to lose those objects. So I want to save them. So next time when I come back, I can still use those variables. So this is how we can do. So for example, I created an X variable and a Y variable, and I can save this Y variable. So this is a save is a function that you can, so you can specify what is the file name for you to save this function. Once you have saved it, this backup.r, so you can name this as anything you like. And this file will appear in your folder, okay? It will appear in here, just like what I have in here after I have saved it. And the next time, even if you have removed X and Y, for example, X and Y, they're missing because I have removed them using this rn function. But as long as I load the data, X and Y came back. So this is how we can access data from using this load function. Okay, so always try to save the data that you have previously used into some kind of R data format, so you can store anything that you want in front of this file argument. X1, X2, X3, A, B, C, and anything that you want, any kinds of objects, a data frame, a matrix, a vector, a scalar, a function, anything that you want in here, as long as the last argument is the file name of the saved object. And next time, use the function called load, and use the arguments called the data, the name of our data. Then you can load the data that you have already backed. Okay, so I think this is utterly the most important part for you to for you to learn in our program, because with our program you want to work with data, and I think the CSV, Excel, and the text file are pretty much the file types that you might come into, and also access data from previously saved objects. Okay. And so once you have loaded the data, then you can play with the data with all kinds of operations. So instead of creating simple vectors, you can deal with more complex data structures with a data frame or a matrix. So using this data loading tricks in here, and you can play with these R codes in here once, if you have this tutorial in here, once you have loaded the data. And yeah, and then I'll stop it from here, and yeah. Okay.
That was very kind of you, Dr. Kao. I would like for the audience to find the reactions button there. And let's give her a round of applause, everybody. That was just wonderful again. Audience, we are in the process of making these recordings available online and creating a canvas so that the support files and so forth. I will make more announcements about that tomorrow. It's all in progress and beginning set up. But I think it's been lovely that so many people can participate. When we planned this earlier this spring, I thought that if we could have 20 students participate, it would really be worth Dr. Kao and Dr. Zhang's and the team's efforts. But it's just lovely to see 61 students still here at the very last minute. Appreciate all of your efforts, Dr. Kao, Dr. Zhang, and look forward to seeing you tomorrow. Bye-bye.
Thank you, Elmer. Bye.
Bye.